Hey, good day, everyone. Welcome to the February chapter meeting of CSINext. I'm your chapter president, Mark Ogg. Today we continue with the great lineup of programs we've got in store for you this year, and which would not be possible without our chapter sponsors. So a special thank you goes out to Bear Corporation, Allegiant, National Gypsum, who is actually our presenter today, and Accu Studio. Your continued support is very, very much appreciated. All of our chapter sponsors' web links are on the CSINext website, so be sure to check them out while you're there. So today we have with us Mr. Warren Barber with National Gypsum, who will be presenting on the advantages of using cover boards in low-slope roofing assemblies. If at any time during the presentation you have a question, just raise your hand through the GoToWebinar application on your computer. I will see it, and when we get a break in the action, we can address some of the questions, and we'll get to you as soon as we can. So with that, I will turn it over to Warren, and we'll get started. Warren, it's all yours.
Thanks, Mark. Appreciate it. Good afternoon, everybody, at least those of you in the Eastern time zone, or good morning for everybody that trails off to the west of us. Appreciate the opportunity to be here. You all know National Gypsum's most famous CSI Next Chapter member, Thad Goodman. Everybody loves Thad, and so appreciate Thad being involved and helping get this coordinated. And so it was kind of fun last year, not kind of fun, it was an honor last year to be there when Thad, your fellow chapter member, received the CSI fellowship. And Frank Fuller with the Dallas chapter works for National Gypsum, and he, those of you in the Southwest know Frank, he attained fellowship last year as well. So appreciate that. And Mark, I can think of no other way to spend Valentine's Day. This is a romantic setup to Valentine's Day, talking about low-slope roofing. We do talk about fire in here a little bit, so I think that covers us for Ash Wednesday as well. So it's an awkward day. It's a day of love and a day of piety. So anyway, enough of the cultural references. I have spent a good part of my career calling on architects and calling on the specification community. CSI is a big part of National Gypsum's marketing efforts as we try to influence the specification community. And 4 years ago, we got involved. Yes, sir.
Just for a second, I got a notification here. The operations window there that says the file options view up there in your right hand corner. Can you minimize that? Because evidently that's showing on the present. Oh yeah, I can see it now. It's showing up. There we go. Thank you, sir. Okay.
Thanks. Technologically challenged. Thanks, Mark.
Yeah,
so,
but
but I spent most of my career with architects and with the AEC community, and for the last 4 years have been managing National Gypsum's architectural efforts, and then also managing our glass mat gypsum products, including some that we'll talk about at the end of the presentation today. But we got involved about 4 or 5 years ago in low slope roofing, and that's what we're going to talk about today. So when I minimize this, Mark, what tends to happen is then I lose my ability to advance the slides. So let me try this. If we go here, can you see the presentation now?
Yeah, but I still see I can see the present. There we go.
All right, so we got it now. Okay, thanks for everybody's patience. So this is an AIA certified presentation. You get 1 HSW credit for the presentation. It's a registered National Gypsum presentation as well. If you want slides, or a copy of the presentation, Thad, or I can get it to you, or we can get it to you through Mark in a PDF format. And for those of you that are AIA members, you can go online and do the course evaluation that way as well. And then again, we're just going to talk about low slope roofing. We're going to talk about some of the performance factors that come into play with roofing. If you tend to multitask, or if you're eating lunch during this and the MSGs kick in, I'll tell you, right up front, the premise here is when you're doing low slope roofing, when you're designing or constructing or helping an owner manage their facility like Mark does, then use a hard cover board, and we make 3 of them, so we'll talk about those at the end. But so we're going to talk about, again, reasons why to use a cover board, some of the different types of cover board that are available out there. You'll hear me use the term hard cover board as opposed to cover board, so we'll talk about that in a little bit. And then from a performance standpoint, what cover board should you use where? So that's really where we're going to go over the course of the next 45, 50 minutes. So again, when we talk about low slope roofing, this is a little bit elementary, but the definition there is a 3 and 12 pitch, or for those of you that aren't familiar with pitch, if you think back to high school biology or high school earth science, it's the rise and run that we looked at in geology. But if you see across the top there, 3 and 12 would be you rise 3 inches for every 12 inches that you span on the roof. So, and if you look at it in that blue box, 3 and 12 does have some pretty good pitch to it. So anything less than that is what we would consider to be low slope. If you do 0 and 12, then you're going to have a swimming pool and you're going to have issues on your roof. So we're going to look at some of the elements that come into play there. And like anything with the building envelope, and I'm sure you've read and studied a lot in the building envelope, if we just did a roof and didn't have penthouses up there, if we didn't have penetrations, we didn't have hatches, we didn't have skylights, it would be much easier to design. Same with walls. As a gypsum sheathing manufacturer, we kind of like walls without windows because that helps us sell more sheathing. But we also know that that's not really good for the occupants of the building not to have windows. So there's a lot you have to take into consideration when you have other things going on your roof, like multiple levels or a penthouse. Managing those transitions, like anything in the building envelope, is very important. So we'll talk about some of those elements as we track through the presentation today as well. So let's talk about just some of the very elementary components to low slope roofing. And again, I'm not an engineer. I'm not a registered roof consultant through RCI. And we're not going to turn you into those at the end of this hour, but just to give you some exposure of some of the things that go into low slope roofing. And sometimes firms will use a roof consultant, or they'll have one architect in the back someplace who does the roof detailing, the roof specs, or they'll work with a system manufacturer and work with them. That would be a membrane or a roof type manufacturer, and we'll work with them to detail their roof. But first of all, let's start at the deck, and we'll work our way up. So you see at the top left there, you've got steel deck, and then the insulation you see is mechanically attached. Notice that the fasteners go into fasteners are attached to the raised ribs of the deck, and sometimes you'll see fasteners get shot into the lower part of the web, but you want to attach to the top there, obviously. Lower left, you have a lightweight poured concrete roof deck. If you are in old cities, Marks and Cincinnati, some of the old cities will have a lightweight gypsum deck that's been poured. You don't see that as much anymore. And the third type of deck that's typical there is on the lower right. You'll have a wood deck. Now you see this is a plywood or an OSB deck. We've done a lot of wind uplift testing for the West Coast with OSB for a couple different system manufacturers this past year. what you're typically going to see, and we'll see on some blow-off pictures later, wood deck, a lot of your old cities, if you're in Detroit or Cincinnati or Cleveland or New York or Chicago, you'll see wood plank deck. Not uncommon to see in some of your old warehouses and some of your old buildings that you might be renovating. So obviously OSB and plywood would be newer inventions or newer additions there. So look at the wood, the scorching of the wood there. And we'll talk about that a little bit later, but typically that goes into the not good column when you've scorched your wood. So there's our deck. And then next up, we're going to look at, back in the early days of coverboard, in a lot of cases you weren't using much or any insulation. But now, with the energy codes and just general requirements and thermal efficiency of buildings, we're using quite a bit of insulation up on our roof, especially in the northern zones. So your three most common type, the most common is polyiso, and that's, you see that in the lower left. Typically that is, originally it was faced with paper, organic facers. I think most roof consultants now would specify a polyiso that has a coated fiberglass facer. So we'll talk about polyiso a little bit later in the presentation as well. EPS on the top right, the white beadboard gets used a lot on roofing, and then on the lower right you've got your XPS, your extruded. So your pink board or your blue board typically is what you see there. So there's the jury is out on what type of insulation to use, and you can read journal articles and trade publication articles in all three, polyiso, EPS, and XPS, all will tell you that they give you the best thermal performance in the roof over time. So sorry about that jump there. I'm not sure what happened, but so again, insulation on the roof, we'll see that fairly obviously used more and more. In the early days, when we were talking about membranes, and you're introducing a cover board, when you didn't have much insulation and petroleum prices were low, adding a component like a cover board added a lot of cost to a project. Now, with more insulation and membranes or built-up systems or mod bit systems being petroleum-based, having a higher cost, you're still adding cost to a roof by adding a cover board, but it's more right-sized cost versus being the highest, most expensive component. So looking next, we've talked about our deck, we've talked about insulating our deck. Next is how are we going to attach this roofing system? And it's more complicated than I make it, but generally you're going to glue it or you're going to screw it as you put it down. So top left there, you'll see we're putting in fasteners with aluminum galvalume plate. So mechanically attaching it that way. What we're seeing a lot more of in the last couple of years is that top center picture, low-rise spray foam. This is put down in ribbons, but also the system manufacturers are testing it using a splatter type of pattern, and then you would walk your insulation or walk your cover board into that. So here you'll see them, they're using low-rise spray foam to adhere the insulation to it. Ballasted roof on the top right, still used, specifies much less commonly than it was. Obviously, there's a lot of well-publicized cases where you've had ballast become propulsion objects in hurricanes or tornadoes, and bad for windows, bad for cladding, bad for the autos in the area. So I don't think today Factory Mutual warrants roofs that are ballasted, but you still see it in use. Lower left-hand corner there, we see hot mop for attachment. We'll talk about hot mop in a little bit. And then another area that's like the low-rise spray foam that's gaining a lot of popularity would be the use of cold applied liquid adhesives. So again, they're low VOCs, pour them out of the bucket. You don't have to heat them. You don't have to pump them up onto the roof. So again, we're seeing this low, the cold applied adhesives becoming much more common. And then the next section we want to talk about is looking at our system components. How are we going to cover the insulation and the cover board? How are we going to make this roof system watertight? So the most today, and the numbers I'm going to give you are actually 2016 numbers that are published by NRCA, the National Roofing Contractors Association. And so the most common by far type of roof system is what we would call single ply. And the biggest of those, the most commonly used and probably the fastest growing is TPO, and that's your thermoplastic type of membrane. You see that in the top left, and that's being adhered, and then the seams are mechanically attached there. The second largest is probably EPDM. That's the lower left. That would be your traditional rubber membrane, and that was the original of the single ply membranes. And then on the lower right, you've got PVC, PVC has gotten beaten. Sorry about that. I'm not quite sure why my presentation jumps there, but so PVC. Apologies there, Mark. My computer jumps back, but back to the slide view. But PVC is sometimes people call that the restaurant roof because it's inorganic, and with hood vents and things like that in restaurants, it's not going to degrade it. It's easy to clean, but typically you're going to heat weld your seams on your PVC. So in 2017, the single ply, we belong to an organization called SPRI, Single Ply Roofing Institute. Single ply in 2017 was 3.7 billion square feet, and that represents about 75% of all low slope roofing. In 2000, single ply was about 11% of the industry. So my Surface Pro is not acting like a pro today. I don't know if you see that screen jump.
It happened.
So I just appreciate your patience with it. So looking at the numbers, single ply is about 74%, 75% of low slope roofing, and that was the number I just gave you is 3.7 billion square feet. Under single ply, you have cover board of about 800,000 square feet. So a lot more. When people say, we're getting into low slope roofing, and our competitor, we have competitors that have been doing this for 30 years and 10 years. We like to say our biggest competition is no cover board, having a roof without a cover board. So single ply is the biggest there. The second largest group probably is what we would call mod bit. These would be asphalt-based systems, modified from the old built-up that we'll look at in a second. But you've got your APP or your SBS. APB is typically, you're going to torch the membrane down. You see that in the top right. Torching to the membrane, not to the wood deck like we saw on that slide previously. And typically what happens is that torching then liquefies the asphalt in the membrane, and so you heat it down there. Lower left, you'll see where they've mopped it in. You can either mop it in with a cold adhesive or a hot adhesive, and then they're putting the cap sheet down on top of that. So mod bit represents about 10% of commercial roofing, after the 75% of single ply. And then the third type of system there is the old built up. And back in 2000, when single ply was just hitting the market, built up was about 45 to 50% of the industry. So built up today represents about 6% of low slope roofing. So in the You still see summertime built-up roofing happening on schools, and it seems like the Midwest is one of the and Texas are kind of the two last bastions of hot built-up roofing. I have a so my favorite analogy of built-up is any of you who are fans of Shawshank Redemption, the roofing scene where Andy's up on the roof, and at the end of hot mopping that roof, they talk about having a beer, drinking a bottle of suds, and feeling like a man again. That's built-up roofing. So we've been doing that for decades and decades, and it's a good roof from a waterproofing standpoint. You see the smoke and the steam coming off that hot. There's a lot of VOCs involved. You really can't do built-up roofing while the building's occupied. It's going to be too difficult for the people inside. You can't see it today since we're doing a virtual chapter meeting, but I've got a picture from the Charlotte Observer from last fall. So the caption of the picture says, and it shows the fireman putting out a fire, and it says, "Cart of hot tar catches fire." So a roofer's kettle caught fire, and actually they're working on this could be some poetic justice here, but they were doing some repairs on the Mecklenburg County District Attorney's office, and the kettle for the built-up roof caught fire. So anyway, it's just there's probably some environmentally some not so good things about doing a built-up roof, but it's worked for years and years and has been successful. But we're seeing it shrink every year. We talked about fluid applied earlier with cold adhesive, and again, you don't have the heat, you don't have the fire, you don't have the pumping that you have to do, and this is readily gaining acceptance, both as an adhesive, and sometimes people are using fluid applied systems to extend the life of a roof to give yourself another 4 or 5 years before you'd have to do a major roof job. So fluid applied, again, it's niche-y, but we're seeing it used on a greater basis. Most of your membrane manufacturers or your mod bit manufacturers have fluid applied systems that they're promoting as well. PMMA is a term that you will hear used when referring to fluid applied roof systems. And then the fourth one is, again, niche-y. Those of you that have been hanging around building science the last few years, there's a lot of discussion about the use of spray foam, both on the roof, on interior walls, exterior walls. And so you'll see, especially out west, you see that picture in the lower left-hand corner. It's kind of, you see that you're in an arid, mountainous type of environment. So the dry climates out west, you'll see, in Colorado, California, you'll see spray foam used as a roof membrane or as a waterproofing for a roof system. It's interesting. It's hard to see that picture on the lower right, but you see that the applicators here wearing hazmat type uniforms as they apply the spray foam. Then you see the guy holding the hoses there in the lower right. He's got street shoes and a white dress shirt on. So 3 feet back, apparently they haven't identified as dangerous, but it's kind of I always get a kick out of some of the pictures that we use here. But again, spray foam is niche-y, but it's out there, and in arid environments, it does prove to be a good roof system that you can use. So we've talked about the roof deck, the insulation, how we fasten it, and we've talked then about the different systems that we use. And just from probably from a number standpoint, spray foam that we just looked at, that represents about 2% of the market. So again, it's a growing category. Another one that we didn't talk about would be standing seam metal roofs. That's about 5% of low slope roofing. So we haven't talked about those, but they are niche-y and they are out there. So why should we use a cover board? I told you if you're gonna check out on me early, use a cover board. One is not aesthetically, but just from a performance standpoint, it gives you a good hard flat surface to put your membrane down on. So protect the membrane above, protect the insulation below, and we're going to talk in a little bit about some of the factors that come into play and why you want to use a hard cover board for those different applications. And then protecting against, again, from an impact standpoint, protecting against storm and damage, and you can greatly improve your wind uplift ratings by using a hard cover board. So for coastal areas or high wind areas, use of cover board really helps to enhance your system. Two nice reports that have come out in the last 15, 16 years that support the use of coverboard. It's one thing for me to sit here as a manufacturer and tell you that you should use, so it could seem a little altruistic as a manufacturer. I want you to use hard coverboard because the baby needs shoes. We get that. But in 2000, the National Roofing Contractors Association put out a bulletin that really recommend, if you're using polyiso, then they recommend the use of a coverboard. And then in 2006, the MRCA, the Midwest Roofing Contractors Association, which is the largest association of the largest regional association of national roofing contractors, came out and said, recommended specifically the use of a glass mat coverboard. So again, you'll see some of the bullet points there, talking about if you're using polyiso. Some roof consultants like Renee Dupree and Mark Dupree up in Wisconsin will say any type of polyiso, whether it's high density or regular polyiso, you should have a hard cover board over that. So, they're talking about either gypsum fiber or fiberglass mat gypsum board to be used here. So that's a nice bulletin. And then here's the call outs from the MRCA bulletin that came out in 2006. So again, roofing contractors recognize the performance enhancement that you can get from using a hard cover board. So what we want to take a look at now is, what are some of the different types of cover boards? And there's 5 main ones that we're going to talk about. There's 9 or 10 different cover boards that go into this category. But we're going to talk about glass mat, fiber gypsum. I just mentioned cement board. Use of cement board on roofs is relatively new compared to glass mat or fiber reinforced gypsum. High density polyiso. I mean, most of this gypsum, or not gypsum manufacturers, but most of the roofing system membrane manufacturers also manufacture or have a private label high density polyiso that they use. And then wood fiber board, from an economic standpoint, is still pretty widely used. So we're going to look at those 5 and some of the performance enhancements. So again, glass mat gypsum board has been used as a cover board and a thermal barrier in roofing for probably the last 30 years. You can get a coated mat but unprimed board that you would use for mechanically attached projects. You'll see that in the picture to the right here. So you're going to screw through this either as a cover board or as the thermal barrier on the deck. Then you also have a primed glass mat gypsum board, and that would be for your fully adhered systems. So that's where you'd glue that down, whether it's a peel and stick or you're using some type of adhesive. You'd use the prime board, and the primer on the board, it's a non-asphaltic coating that we use on the face of the mat, and the intention there is to give you holdout, so your adhesive doesn't soak down into the mat and soak down into the gypsum. So it keeps the adhesive up on the surface, and you get better coverage and better adhesion when you do that. So that's the intention there of a pre-primed board. You could prime in the field regular coated glass mat, but that's going to take time and additional labor to do that. So you can have the prime board. The second one that we talk about is high density gypsum. It's reinforced with, it's a high density gypsum fiber board, and that's reinforced with cellulose fibers in the core. So two ways to keep your gypsum core strong and dimensionally stable. One is either to put the fiberglass facers on it, or if you do a monolithic approach like this product, then you would press the gypsum with the cellulose fibers in there. So the difference there would be cellulose is organic. It can absorb water and swell and move when it gets wet, where your fiberglass facers on a glass mat gypsum panel would be inorganic, and they're not going to have that movement. So two different technologies that you can have there to add strength to your gypsum. And then again, I mentioned cement board is relatively new. You'll see in that upper right-hand picture, you'll see the low-rise spray foam being used to adhere the cement board. So cement board would be the tagline I like to use is the board to get whenever it's wet. And also cement board has great nail pull values to it, so you get some great wind uplift values from using a cement board. But anytime you have wet manufacture, either it's wet inside the building or you're trying to have extra risk of moisture outside the building, then cement board is a good alternative to use. It's not used nearly as gypsum. It's not used nearly as much as fiber gypsum or as glass mat gypsum, but it's a nice niche for either high wind uplift coastal applications or those wet applications. And then the last of the five that we're going to talk about would be wood fiber. And this is generally either, it's from a sustainability standpoint, it uses a lot of recycled content because you're using wood fiber from wood, either lumber or OSB or plywood manufacture, or even wood residue from a paper plant, that sort of thing, or cane fibers from sugar cane is used. So wood, two things I learned from my mother. One is mustard stains, and the other is that water is wood's biggest enemy, except for maybe fire, like we saw in that earlier slide. So you can say, was my mother a building science person? No, but she taught us some hard lessons in life about leaving water rings on end tables and coffee tables. So water and wood don't mix. I learned that early on in sitting in my mom's living room. So again, wood fiber, it's not going to manage water well. It's you can hot mop to it in those applications we talked about with built up, but you certainly can't torch to it, obviously. And moisture has some bad effects to it. So, and then the last of the five we'll talk about, again, this is like cement board is fairly is newer on the cover board scene. It's the polyiso manufacturers make what they call a high density polyiso, and that would be typically, again, with fiberglass facers. They call it high density, but the density generally is greater than 80 psi, usually between 80 to 120. So if you're feeling strong, you can take a piece of high density polyiso and squeeze it, and you can get some compression there. So I would say the high density part is relative, and there's especially wind uplift applications. It's not going to give you that much wind uplift. So we say high density is relative from the standpoint 120 psi and high density polyiso. The psi on a glass mat gypsum board is generally 700 to 900 psi. Gypsum fiber and cement board are going to be psi's are going to be up over 1,000. So it's 120 versus 1,000. That's why it's relative. But again, the system manufacturers make it, and there's applications where it is an acceptable cover board if you don't need certain fire ratings or don't need the wind uplift rating. So that's the five. This is just a little chart, and we can make this available to you, that kind of shows the different systems that we've looked at and where these boards fit in. If you look down there, the sixth one listed, Perlite, back 10, 15 years ago, Perlite was a huge cover board. and it's still out there. Usually perlite now is used for accessories like cants and some things like that for the edges, and not necessarily used as a cover board. So let's look at some of the external factors then that affect the performance of your roof system. Love our icons, and so we're going to talk through some of these. You know, the big one that generally we talk about with roofing, we talk about wind uplift, and there's a lot of variables that come into play there. There's a group that was formed out of the Roof Consultants Institute called RCOE. If you're familiar with them, they're a forensic group that's gone out, made up of roof consultants, architects, roof contractors, roof system manufacturers, and they go out. I mean, they're storm chasers, so they'll go out after a hurricane and do forensic work on roofs to see how they performed with the deleterious effects of storms, primarily hurricanes, and they really found that use of a cover board is going to help keep that roof system from blowing off. So you see that upper right-hand picture there. You've got you see the old wood planking that I talked about from a wood deck in some of your old warehouses and some of your old cities. So depending on where your building is, the height of it, what your wind, what your typical wind speeds are. You talk about Chicago or your major cities where you've got your wind tunnels from all your buildings. That all comes into play when you're talking about wind uplift. So when we talk about roofing, Factory Mutual is the 800-pound gorilla in roofing when it comes to testing. A lot of their testing is around wind uplift. And obviously, because they are an insurance company and they insure buildings, then Factory Mutual is obviously concerned about keeping that roof on that building. So where UL is kind of the 800-pound gorilla when it comes to walls and fire testing, Factory Mutual is the big influencer on testing for roofs. So again, wind uplift, you'll see in the upper left-hand corner there, you go through a series of cycling pressures, negative and positive pressures on that roof. You see where the dimples there would be where your fasteners are on that deck, and generally this is a 12 by 24 deck that they're testing here. Lower left there, typically where your failures are going to be is in your deflection is either you're going to tear a seam on the edge of the membrane, or you're going to break the cover board. The plates, the fastener plates are going to bend, your cover board will break. And those are generally the failure points in a roof. And then lower right, as you know, when you'll have different fastening patterns on a roof. Your greatest wind pressure is in the corners as it negative and positively pressures on the back side of that parapet. So you'll have greater fastening patterns in the corners. Then the perimeter of the roof takes the next greatest amount of pressure from the wind, and so you'll have different fastening patterns for the perimeter. And then the field of the roof, you'll have different fastening patterns yet again. So in our literature, we publish fastening patterns anywhere from 6 to 32 fasteners. That would be one per every square foot on a 4x8 sheet of board. So, and Factory Mutual is continually changing their standards. So there's a lot of talk in the industry now where a lot of your fastener, your perimeter of the perimeter fastening requirements are extending farther into the field of the roof. So sometimes 12 to 20 feet perimeter is what they require. So you need to take a look at what the Factory Mutual testing is. So FM 190, a 90-speed wind rating is typically the basis that you'll have for design, but you can have ratings up to 1150, 1120, 1135, not uncommon. So the more fasteners you use and the heavier the cover board, then the greater wind uplift you can get with that. So we have wind uplift, probably the greatest factor that we look at. Fire resistance, obviously, is of great concern. Again, Factory Mutual is a leader in fire testing for roofing. So you can have a Class A and a Class 1 roof. So Class A, B, and C typically is fire from without, and Class 1 would be combustibility from within the building. And so you can have a Class A roof, but it's not necessarily a Class 1 roof because it's more extensive testing takes place for a Class 1 roof. But a Class 1 roof will be a Class A, if that makes sense. So again, you're testing from within and from without. The other testing body that does a lot of testing, like we mentioned, is UL. In UL, you'll have the burning brand test. Again, you've got Class A, B, and C, and A would be the most severe, like you have with the Factory Mutual in the previous slide. The burning brand test and the intermittent flame test, those would be for combustible decks, your wood decks, and then your spread of flame in the lower right, the E84, the Steiner tunnel test. That's done on all building materials, but that would be for both combustible and non-combustible decks. So I called my mother once and said, I'm getting paid to watch wood burn on a roof. And the burning brand test, you have to wait until, until the fires are out, the fire is out, but until the embers have all died down as well. So it's a boring test. It's kind of exciting at the beginning when you see the stack of wood burn, but then standing there waiting for the embers to go out gets kind of boring. But you're getting paid for it, so it's not a bad day. Beats a day in the office. So again, wind uplift. We talk about fire. Next, let's talk about impact. And when we talk about impact, what really gets a lot of the attention is hail. But we'll talk about foot and human impact in the next slide. Factory Mutual, again, is big in hail testing. So they'll freeze ice balls and then drop them or project them at roof systems. And it's a little bit counterintuitive, but you would think with a hard cover board underneath the membrane, a hail ball would create more damage. But really where the damage is when the hail ball impacts the membrane and then it flexes and the insulation below flexes. Then once it flexes enough, it's going to split the membrane or scar the membrane or tear the membrane. So a hard cover board, your membrane will be hit, but with the hard protection underneath it, then that hail ball is going to bounce off and it's not going to penetrate the membrane. So there's severe hail testing protocol that Factory Mutual is just getting started now, and we're looking at that primarily, especially with our cement board. But typically you think of hail for those of you in Texas, Oklahoma, the big hail states, but they're expanding that severe hail area. So when I was in Denver this summer, there was those of you in the mountain states, there's a large outlet mall in suburban Denver that was impacted by a hailstorm in May, and it broke skylights and severely damaged the roof, and the outlet mall was closed until probably November of this year. So you lost 6 months of revenue for a shopping center. So if you're an insurance company and you're insuring profitability and the ability to keep that building open, then that's a huge exposure, huge liability. So you're going to see and hear and read more about hail and severe hail, and that severe hail zone is getting larger. Taking up a larger, not just the lower Midwest or the Southwest. So more on that. But I would say of greater consequence to your roof and greater impact to your roof is the human factor. It doesn't get as much attention as hail does, but it's not uncommon if you can look out on buildings or you're up on roofs. Obviously our HVAC systems are more and more complicated. If you have a data center or something like that, you've got a lot of humidity control and a lot of HVAC units up on that roof. And, most of your plumbing and heating technicians don't weigh 135 pounds and walk lightly. They won't walk on the walkways. They'll cut right across the roof to that equipment. So you drop a wrench, you have a heavy person up on that roof a lot, then you're going to slowly crush the insulation underneath. And again, that's where you need a hard cover board underneath your system. Or they'll use the lower roof as a staging area to put materials up on a higher roof and re-roof. So again, you need a hard cover board underneath there to help with your human impact, in addition to the hail impact that you have taking place on your roof. And then moisture is obviously a concern in roofing. The statistic used to be, the cost of a roof was about 8% of the building, but 80% of the litigation in building envelope comes out of the roof. But I think, some people, Dennis Hall and others have told me probably that litigation piece has slid off the roof and down the wall with building envelope, with leaks in windows and leaks in the exterior facades. But again, keeping that moisture, the whole idea of a roof is to keep the moisture out of the building. So, we build buildings wet, we all know that, so you can get moisture introduced into your roof system during construction. We can have leaks for all the reasons that we've talked about previously here. And then probably your biggest your biggest source of moisture in a building probably comes from the occupants, people. And so, we talk about, I talked about cement board earlier, the board to get when it's wet. So, we think about wet manufacture, paper plants, natatoriums, where you're going to have a lot of humidity in that building, and a lot of condensation that can occur up in that roof assembly. But also just a school full of little Johnnies running around, and sweaty little kids, can produce a lot of condensation up in that roof system as well. So we have a competitor who has launched an ad campaign about how their product performs in a wet roof. But the whole idea is to keep the moisture either from underneath or moisture from on top out of that roof system. But a hard cover board, especially the glass mat or cement board, can really help you manage moisture as it wets in and dries back out. So moisture, big concern. And the last one is sound. So we don't really think about sound suppression or sound dampening so much for the roof. But a lot of the acoustic testing in roofs has come from airports. So if you think about the next time you're in the airport terminal waiting for a flight, and Thad and I spent a lot of times looking at chasing cranes, and we get there by going on planes. But if you think about, unless you're standing right by the glass, where around an airport don't you hear the planes? And it's generally in the terminal. Unless you're right by the window. But there's changes in LEED version 4 now, puts a lot more emphasis on indoor environmental quality, and acoustic control is part of that. So National Gypsum just wrapped up in December, probably the first, the latest, struggling for my words here, but probably the most comprehensive acoustic testing in roofs that's been done in the last 10 years. And we've just published that now. So we've been able to, typically when you think about acoustics, it's what you do below the roof deck, with your suspended ceiling system, or with insulation or resilient channel or hat channel. But what you do above the roof makes a difference as well. So if you add mass, add cavity absorption there. So we've been able to attain STC of 61, and then an outside noise coefficient of 50, which is big. So again, for schools, convention centers, for areas around roofs, or even around highways where you get a lot of sound leaking through that roof. Acoustics, we're finding acoustics is playing a bigger role in roof design and roof assembly. So if you need some help there, you can touch base with us. So again, we saw this overview chart earlier when we looked at the different type of roof systems. Here is just, again, looking at those 5 or 6 different factors that we talked about. One, that far right column, we didn't talk about that with the icons, but dimensional stability is of great consequence. Obviously, you don't want components in your roof moving. Polyiso and high density polyiso does have a track record of shrinking. So you don't want gaps underneath your membrane. If you have fiber, like wood fiber or fiber gypsum, if you've got fiber in your core, there's opportunities for thermal expansion and contraction, and moisture, hygrothermal, I guess, expansion and contraction. So you need to be careful with what type of components you're using. Just to gypsum has a very low coefficient of expansion and contraction, both with temperature and with moisture. So it's a good stable basis to build your high performance roof system from. So we're about there. Just in summary, again, we've talked about, I told you at the beginning, if you're going to tune out on me, if you're going to do a roof with a hard cover board. And I think we've talked about the difference between cover board and hard cover board today. So I will say thanks for the opportunity and to present today. And Mark, I'll kick it back to you if we've got any questions from the group.
I've got a couple questions here, a couple comments actually. One just came across. Very good presentation, and that person did not zone out. So you did a great job of keeping everybody's attention.
Right.
I thought it was very good, very informative. As a construction manager myself, one of the most problematic areas on a building, not only from a construction standpoint, but from a maintenance and warranty and operations standpoint, is always the roof. And that's something that I always try to pay attention to. And the more options there are out there to work with better products, work with better applications, I'm always welcome to hear about those from manufacturers and suppliers. I was very, very impressed with what I saw today, and it was honestly something that I haven't been exposed to. A couple questions I do have. One on the dimensional stability part of it. What kind of effects, and maybe you know and maybe you don't, have you seen across the country? I know with you being down there in North Carolina, I'm up here in Ohio, so we're kind of on the East Coast, kind of in the Midwest. I know we've got a couple members on today that are out on the West Coast, out in Arizona, etc. With the Midwest weather pattern that we've seen over the last 10 years, I mean, you know as well as I do that you guys and us, we can be 55 to 60 one day and 15 the next. What kind of, have you seen a lot of, are there a lot of problems with the dimensional stability? How does that product react in the Midwest, kind of where we're based at, versus other areas of the country? Has it been more reliable in that aspect as far as expansion, shrinking,
I think
movement?
Probably, yeah, that's a good question. And probably the most dimensionally stable of the cover boards we talked about are the glass mat gypsum cover boards. Basically, if you have a day where you have a temperature swing of which you can have, of 50 or 60 degrees, and you have a humidity swing from low humidity to 90% humidity in the afternoon, that sort of thing, gypsum will move about a half an inch in 100 feet. So on walls, in interior and exterior, we suggest having a control joint Up on a roof, typically you've got so many penetrations and so many things happening, and you do have control joints there as well, that gypsum doesn't typically come into play. So that speaks to dimensional stability of gypsum. Polyiso, the PEMA people and the Polyiso Institute, they've done some work on reducing shrinkage of insulation, but it's pretty well documented that you're going to have some shrinkage both in thickness and in dimension. So I think they would say it's less than 5%, but on a 4x8 sheet, a 32 square foot sheet, 5% shrinkage could be a half an inch. So then you've got, you have a gap that opens up, and there's opportunities there for your membrane not to be protected underneath it. Gypsum fiber is going to be dimensionally stable. Where there's going to be an issue there is if moisture gets into your roof system, then that cellulose in there can expand, especially at the cut edges on the perimeter of the board. So you can have cupping. So I think the gypsum fiber manufacturers generally recommend that you gap the board, maybe 3/8 of an inch, which is difficult to get a roofer to do. Or if you gap it, then people walk on the roof, the boards slide, and you lose your gapping. So I would say probably gypsum would be, glass mat gypsum would be the most dimensionally stable, then fiber reinforced gypsum, and then polyiso.
Okay. So overall, cover boards perform pretty solid.
Yes. Yep. Absolutely.
That's
if you look at,
at least up in our, and I know down where you guys are, because you guys get all kinds of different weather patterns day to day down there in North Carolina, like we do up here in Ohio.
Right.
I mean, you can have snow one day and sunshine and 70 the next, and then you're back to 20-degree weather with winds the next day, and it can cause a lot of problems just beyond the roof. But I mean, that's one area that we've seen some issues with, as buildings expand, contract, and material shift around. You start to have problems.
And then the other sidebar to that, then, Mark, is really, there's a whole school of thought out there about cool roofs, and when do you use a white membrane and when do you use a black membrane. And now, and I'm not going to wade into that really, but there's the city of Chicago had a cool roof initiative early on, and now we're kind of finding in some of the northern climates, you probably want a darker roof just for that roof system to heat up enough during the day, especially in the winter, to help dry it back in, get the humidity back out of the system, dry it back down into the building. So again, a lot of journal articles written about that, but the temperature swings and the humidity swings are a big deal for expansion, contraction, condensation, evaporation in your roof system. And there's obviously a lot of building and science behind it, just like in our walls and below grade as well.
Okay. Another question / comment here from another one of our members is, and I'll just try to summarize this here, but I know there's always, when you're designing a project and specifying a project, there's always that line over what's recommended versus what's required, and you get into the application of it in the field, and you have contractual issues, who recommends it, who requires it, et cetera, et cetera. Sometimes, specifiers or manufacturers will recommend that something be used with their products. So let's say, for example, they're recommending the use of a cover board with a particular type of roofing system, and then say through, for lack of a better term, because it's not one of my favorite terms, but for value engineering purposes, let's say before an owner goes to contract on a facility, that they value engineer that cover board out. Say the construction manager says they don't need it. And then, would there be any favor for requiring it? Have manufacturers thought about maybe requiring it? Is there advantages? I know we're running close on time here. That's probably another question for another time, but if you could touch on that in 15, 20 seconds, I think we'd be good.
And No. Well, obviously with everything, value engineering comes into play. And the analogy I used early on of you are adding cost to a project by using a cover board, but you also are greatly enhancing the long-term performance of that roof. And with the added insulation we're using now and more expensive membranes, it's more right-sized in cost. If you look at like in a single ply, if it's a 30-year roof, you're going to get a 30-year warranty, you're going to have to use a cover board. And a lot of the 20-year warranties require the use of a cover board as well. If you're using mod bit manufacturers require the use of a cover board. So if you want help with value engineering, get your manufacturers involved and we'll help support it to the best we can. But at the end of the day, we can help support it, but value engineering is a reality that we face.
Yep, yes it is. And I've got one I think this is probably a fairly quick one. When would you recommend a vapor barrier on top of a metal deck to prevent moisture in the roof assembly, or is the deck sufficient?
Well, I'm going to do that one. We don't specify when to use a vapor, when not to. Again, that's going to be probably your consultant would help with that. But a lot of times in northern climates, I don't think the code necessarily requires a vapor barrier, but it's going to depend on how much, what the exterior moisture is and how much moisture is going to be inside that building. So I'm going to defer to your roof consultant or your system manufacturer to recommend when to use. A good question, but we don't typically specify.
Okay, and then one last one here, and we'll call it a day. Under what condition would you use both a deck cover board as well as a roof cover board?
Another good question. Since baby needs shoes, you should always, like in our illustrations, we're always going to show a thermal barrier, and then we're going to show a cover board. But if you're going to use a vapor barrier, then it's good to use like that mechanically attached gypsum or the cement board as the base for your to put your vapor barrier on the metal deck, and then you'd use your cover board above to protect your membrane above and your insulation below. But so you don't see as many, or if you want acoustic enhancement, 2 layers of gypsum, you got more mass in there. But most of the time you're going to see just a cover board and not a thermal barrier and a cover board. But if you're going to use a vapor barrier, a lot of times you'll put that down on a thermal, what we call thermal barrier, a 1/2 inch or 5/8 base, and then you use your 1/4 inch cover board above to protect your insulation.
Okay. All right. Well, we are at the end of our time slot for the presentation today. Thank you, everyone, for joining. Warren, thank you for an awesome presentation. We could probably go on for another hour if we wanted to. Just a reminder to all the CSINext members still on the webinar, we are having a bonus program on Wednesday, February 28th, noon Eastern time. Our electronics chair, Daniel Hargreaves, will be sending out the invites for that. This will be a presentation on 4D scheduling. Integrated scheduling with the 3D modeling capabilities of BIM systems. It will be presented by Mr. Mike Priefling, who is the virtual director of construction for Ryan Companies. He is based out of Tucson, Arizona. And I can tell you it's a pretty interesting topic. I've attended a couple of these in years past on some different scheduling integrated presentations in regards to BIM and 3D modeling, and they've got a great product and a great presentation. I think it'll be pretty informative for all walks in the construction, architecture and engineering industry. So with that, I will conclude today's presentation. Thank you again, everybody, for showing up, and see you in a couple weeks. Thanks.